Give me a lever long enough and a fulcrum on which to place it, and I could lift the world, said Archimedes, or Pappus of Alexandria, or whatever. Anyway, lift the world? How could a human being lift a planet that is trillions of times its own weight?
In order to answer this question, we have to talk about torque.
Torque? You mean the 2004 movie featuring Ice Cube?
Seems your buddy Junior turned up dead.
Whoa, hey, that's my brother.
Feds think you did it.
Agent McPherson, Federal Gang Task Force.
No, torque, as in the rotational analog of force, or more simply put, a turning force. We know that forces cause changes in an object's velocity, while a torque changes an object's angular velocity. That's the velocity of something that spins.
So, like, a merry-go-round?
Exactly.
Oh, so if I push straight down on a merry-go-round, it will spin?
No, you need to apply the force perpendicular to the radius. Maybe if we look at the equations for torque, it will help clear up the concept.
Alright.
So torque is the radius from the axis of rotation times the perpendicular component of the force. This is typically shown as the cross product between the force and the radius, but we made another video for that. As torque is the rotational analog of force, we can logically create a rotational analog of Newton's second law. Let's derive this equation, which should help define what these random letters above are. So F equals ma is Newton's second law, and torque equals force times the radius, which equals mass times acceleration times radius by substituting mass times acceleration in Newton's second law. As it stands, we have torque in terms of linear acceleration, but since torque is a turning force, it would be more meaningful to define it in terms of angular acceleration, which equals acceleration divided by the radius from the axis of rotation. Replacing acceleration with radius times alpha and simplifying, we arrive at torque, equaling mass times the radius squared times alpha.
Wow, that's starting to make a lot more sense. But why did you put mr squared in parentheses?
Glad you asked. The quantity in parentheses on the right is the rotational inertia of the particle about the rotational axis. We can replace this with the letter I. Think of inertia as a sum of all the masses of an object and how they are distributed about the axis of rotation.
So, like how mass can tell us how difficult it is to push an object. Moment of inertia tells us how difficult it is to spin an object.
Exactly. Moment of inertia is the rotational analog of mass.
Got it. Wow, this has been so helpful. So, back to the quote. Since torque increases with the radius from the axis of rotation, I could technically lift planet Earth given I'm an astronomical distance away from it.
Yep, just make sure your lever is strong enough and doesn't weigh too much. May I suggest carbon nanotubes?